Hi, my name is Doug, and today for the experimental value for the cake, I will be adding another egg because I believe that if we modify our cake recipe by adding another egg with the additional egg that we already add, the cake will be denser than the control because there will be more unbound water that does not evaporate from the egg. Now I'm going to add 1 cup of sugar, adding half of a 3/4 cup of cocoa powder, now I'm going to add 1 teaspoon of baking powder, and now I'll be adding 3/4 of a teaspoon of baking soda to the cake batter. Now I'm just going to do a pinch of salt to add it for flavor. And now I'm going to mix the dry ingredients, and no chemical reactions occur once I do this, but once I add the wet ingredients, then some stuff's going to start to occur. And now I'm going to add a half cup of milk to the dry mix. Now I'm going to add a 1/4 cup of oil. Now I'm going to add 2 eggs because I believe that when you add another egg, it's going to add more moisture to the cake and a little more structure compared to just adding 1 egg. Now I'm going to add 1 teaspoon of vanilla just for more flavor. So now I'm going to be mixing the ingredients. So several things are going to happen chemically and physically. So first there's going to be hydration. So water from the egg plus the milk hydrates the flour into gluten and gliadin so they start to form. And then there's also air incorporation when I mix it. So creaming butter and sugar traps tiny bubbles that later expand during heating, but we didn't add any butter, so it's going to be oil. And then for emulsion formation, the lecithin from the eggs help fat and water mix into a smooth batter. And then the extra egg effect is going to be stronger with a more stable emulsion, so we think it's going to be like a more moist. And then the sugar dissolves into the liquid, and the baking powder begins an initial release of CO2. This shows that after mixing properties, the batter thickens, it becomes smooth, and then it holds and traps the air bubbles. Now I'm going to add the boiling water into the batter, so what Mia said is going to make it a little more watery, but then also become more moist in the end once it gets baked.
Now I'm just gonna sit here for 50 minutes and watch it cook. And every 10 minutes, we're gonna look into the oven and check and see how it's cooking.
So for the energy transfer when we put the cake into the oven, so first the thermal energy enters the batter. So the hot air eats the pan by convection. Then the pan transfers heat to the batter, and then irradiation warms the surface. And then when the heat is driven, the ingredients change. So first off with the proteins, or the gluten proteins, they absorb heat and they denature, and then the heat breaks down the bonds so the proteins reshape, and then the coagulation forms the solid structure. And then with the starch, once that's in the oven, the starch turns into starch granules and they swell, they burst and gelatinize because the amylose forms the gel, and it also strengthens the crumb. And then with the fats, the heat melts the fats, so the liquid fat coats the gluten proteins, and then it also limits the gluten formation. And it also makes it more tender once the fat is in the oven. And then with the water and steam, the water absorbs, it gets hotter, and around 100 degrees Celsius, it turns to steam, so it expands. And then with the leavening agents, the baking soda and baking powder, the heat accelerates the chemical reactions, and the CO2 gas forms and expands with heat, and the bubbles grow. So when the bubbles grow, the cake rises. And then the structure settings around the 85 to 100 degrees Celsius range, so the protein networks solidify with coagulation, the starch is fully gelatinized, and gas bubbles reach maximum expansion. Then the cake turns from the liquid state to the solid state. And then lastly, the cooling phase. The cooling phase has the heat leave the cake, the protein starch network stabilizes, and then the moisture redistributes throughout the crumb. So after baking the cakes for 40 minutes, they're both done. So as you can see, the constant is right here, the one that only had 1 egg, while the cake with 2 eggs is right here. We can see a different color change. This egg is more brown because it has more water retention, and there's more water with the eggs compared to the constant that has a little more dark color. You can easily see that the cake with the more egg is risen more than the cake that only had 1 egg. And then That's because with the extra egg, there's more protein, which is a better structure. So the egg proteins denature and coagulate during baking. So it forms a more rigid network that helps trap air bubbles. This strengthens the cake structure, which allows it to rise higher and stay higher instead of collapsing, unlike the constant. Because when we were baking it, it first rose up and then slowly kind of collapsed in on itself. So now we can cut into the cake to see how the crumb texture is. So my hypothesis said that the one with the extra egg is going to be more dense, which I think is true, but we can see when we cut it through the texture of the crumb. So that's what the inside looks like. It's very bouncy, but it's still dense. And then if we cut into the constant, it seems more dry. Yeah, it's a lot more, it doesn't hold its shape. It's a lot more crumbly compared to this. This has a firmer structure, which I said before, which makes it more dense and able to hold itself, while this has a more crumb-like texture. The reason why the cake with the extra egg feels denser is because the added moisture and protein causes more coagulation after the proteins denature, which creates a tighter crumb structure. That's why it's denser and doesn't crumb like that. The additional water in the egg may have reduced evaporation slightly, making the cake feel moister or heavier. So describing the different moisture differences between the two cakes. So the one with the extra egg is more dense. It feels wetter and softer compared to this cake that's more dry, because the extra egg cake retains more moisture because the additional egg proteins bonded to water and slowed the evaporation of the water once the cake ended up being in the oven at 300 degrees or 350 degrees for 40 minutes. The control seems dry and crumbly because there's fewer egg proteins that were able to hold on to the water during the baking process. So going back to my hypothesis that we're going to talk about later, or we already have talked about, is that once I added the extra egg, the cake would have been more dense because of the protein structure. And with this experiment, my hypothesis, we tested it and it is accurate.